Hi everyone. Welcome to CSCI 100 Lecture 11. In this lecture, we're going to talk about another data type and another data structure called the dictionary. Now, before I dive into dictionaries in Python, let me remind you a little bit of what data structures we've learned before. So previously, in a few lectures ago, we learned about the list. And our list was an ordered collection of items. Those items could have been of any type. Here I have 3 strings, and we defined a list by using square brackets and providing the items inside of this list, inside of these square brackets, with commas. And we learned that we could mutate this list by updating the 0th element to be Dindu, for example, here. And we could index into our list to get values out of our list. So we can print the first item in our list, starting from index 0, the second item, and the third item here. When I run our program, we get Dindu, Vijay, Jonathan. Now, lists are handy when we care about order, and when we want to know, like, just a list of items. Just think a grocery list, a set of items. But there are other kinds of paradigms of storing information and working with information where a list isn't enough. In particular, think about the cases where you want to map some particular value to some other value. A good example of this could be your grade book. When you look at your grades, you don't want to just see a list of your assignments or just a list of the grades. You want to see a list of each assignment, and for each assignment, you want to know what grade you got on that assignment. And so lists alone don't do this very well. You would either need 2 separate lists. For example, here, if I wanted to use just lists to represent grades, let's say that my grade here, Alex 95, Vijay 65, Jonathan 70. And yeah, I don't know if I would do necessarily this well. I'll lower it down to 75. You could remember that, okay, well, index 0 is the name, and the corresponding index in the grades list is the person's grade. But this gets really tough to use because then, if you want to add someone else here, so you want to add Dindu, then you have to add the value to both separate lists. You have to remember to do that. So Dindu got a 90. And as you modify these values, you have to remember and update 2 separate things. Also, I'll point out, you don't care about order. When you're mapping your grades, your assignments to their grades, you don't care about what order those are stored in. You just want to make sure that for every assignment that you've done, there is an associated grade. This is where dictionaries come in. So for dictionaries, think just like a regular book dictionary, a word dictionary. We use physical dictionaries to look up definitions of words. And so think how in a physical dictionary, you are looking up the definition for some word. So you go to a dictionary with a word, and for example, the word dictionary. You try to find that word in the book, somewhere in the book, and then you look at the definition that's associated with that word. In Python, the concept is very similar. You have a key and a value, and you're going to look up a value associated with a particular key. I'll mention here, you'll hear these sometimes called maps as well, because you're mapping a particular key to some particular value. So let's talk about this in Python terms. A dictionary is an unordered collection of key value pairs. And you'll see why I have this colon here in a second. But the time to think about dictionaries is when you need to do some sort of mapping. There are so many applications of this mapping. Dictionaries are a super common construct in day-to-day programming and in interviews. And so some examples that I thought of here were, if I have my class roster, I want to map names of my students, of all of you, to your grade on your final grade in the class. Maybe if you're looking at your schedule, you probably have for each class an associated location. So that's a great example of when you'd want a dictionary. Other fun things you can do with dictionaries are maybe you want to look at a book and you want to see what the most frequent word in that book is. Well, that's a great case to use a dictionary because you want to associate with each word the number of times that it appears in some text. So you could build a dictionary and keep track of, for each word, how many times does it appear? Here is what the syntax for a dictionary looks like and how we create a dictionary. Dictionaries are created using curly braces in Python. If you have any programming experience in other languages, these curly braces are often used to denote blocks of code. In Python, we use indentation. So in Python, it's kind of strange to see these curly braces make an appearance. But that is their purpose in Python, is when you see something inside of curly braces, that means that this is a dictionary. And if you just see two curly braces together, an open curly brace and a closed curly brace, that means it's an empty dictionary, starting off with no keys and values in it. And so here we have our key value pairs separated by commas. So here's a key value pair, then a comma, then here's a key value pair, and then there's a comma, and then here's a key value pair. And each key value pair is separated by a colon. You might ask, hey, why isn't it separated by a comma? Well, then it would be confusing. You wouldn't be able to tell whether two values next to each other are supposed to be a key value or if they're part of different key value pairs. So in Python, we create these a key colon value, and then we separate the key colon value pairs with the commas. And here you can see what this looks like if you run this code in Python Tutor. It'll show you what it looks like in memory. There's some key, and then next to it is an associated value. Whoops. Now, for this dictionary to actually be useful, we have to be able to get values out of our dictionary. And we always come with some key in mind. Just like a regular book dictionary, you come to a dictionary with a word in mind, and you want to get out the definition of that word. So here the same thing. You come to your dictionary with a key, and you want to get the value associated with that key. So here, for example, we want to get this person's grade on homework 1. We do this by indexing into our dictionary. Just like we did for lists, just like we did for strings, indexing is done with these square brackets. So open bracket, and then the key value, and then a closed bracket. And then this indexing here is an expression that will evaluate to whatever value is stored associated with that key in our dictionary. So when Python goes to execute this line of code, it sees, okay, I'm indexing into a dictionary, looking for the value, for the key HW1. And so looking at our dictionary here, we search for the key HW1, and then we return the associated value 95. This looks kind of familiar. In fact, it's super similar to a list. It's just in lists, you're always indexing an integer. So you're getting 0 or 1 or 2, and the items in the list always stay in order. Whereas here, this ordering, like which row comes first, which row comes second, which row comes third, doesn't matter. And in fact, it can vary from computer to computer, depending on how the computer decides to run your code. But what's important is that the same key, HW1, will always map to the same value. Now, a question that you might have is, hey, what if I try to get a key that doesn't have a value? And that's kind of the equivalent of going to a dictionary and trying to look up a word that doesn't exist. In this case, Python will throw a key error. And so if you try to look up in grades, give me the value associated with the key exam 1, but you can see in our dictionary there is no key exam 1, Python will actually throw an error. It'll say key error. Very similar to the errors that we saw with lists. If you try to index to a number that's longer than the length of the list, Python would throw an error because that index just didn't exist in the list. Now, so far, my examples have all been keys as strings and values as integers, but it doesn't have to be that way. Inside of your dictionary, you can have any types. And in fact, they can vary. So the keys can be, this key can be one type. You know, in this example, all of my keys are strings, but they don't all have to be. They can vary. And you can see here examples where the values vary as well. So title here is a string, the year is an integer. The actors is actually a list, so you can have lists as values. One important thing I want you to know, though, is that the key has to be immutable. And that's because you don't want your key changing on you. You want your key to be consistent. And so, kind of like in a dictionary, you can update the definition of a word, but you can't update the spelling of a word because that would make it a different word or a different entry in your dictionary. And so keys should always be immutable. And so far, of the types we've learned, ints, floats, booleans, and strings were all immutable, but lists are mutable, as are dictionaries. So your key cannot be a list or a dictionary. The value, on the other hand, can be anything. So it could be mutable or immutable. So ints, floats, booleans, strings are all good for values, as are lists and dictionaries.